Okay, here we go. First video I'm preparing is about common tones under transposition. And before we get into the set theory, meaning, and techniques involved, let's go back to traditional music theory and see what common tones are and remind ourselves why that's an important topic. So let's say I have a C major triad and an F major triad. So this might have been theory 1 or theory 2. And we want to connect those two chords. Traditionally, what's considered the best voice leading here? Well, you'll notice that C is the only common tone between these two triads. And so, if you remember, we want to keep that C in place in the same voice, the tenor in this case. And the other voices, alto and soprano, moving by the closest possible motion. So obviously knowing that we chose a chord that is of the same type, both are major triads, and has a common tone, makes this progression somewhat more common, or much more common, somewhat more preferred than progressions that might not have common tones, or at the very least, when we don't have common tones, we have to be more cautious with voice leading. So let's go back to set theory, and I'm in the Jupyter notebook where we have Music 21 in our library of additional functions. And what we're going to say that now that we know what TN stands for, how we use transposition of sets. For example, T1 is 047. T1 of 047 is 0 plus 1, 4 plus 1, 7 plus 1, gives us 158. Clearly here we don't have any common tones. And we say under transposition just because we're defining them as functions. It's mathematical terminology. So what happens if we want to see those as notation? We can see that there are no common tones. What about if we have two half steps? We add 2 to each one of the notes in the original set, and can make a little code here that does that. And it tells us, example 1, 2, T2 of 047 will be 269. Again, there are no common tones. So we started with C major. We can print the original chord again. I'll put the example on top. Sorry about that. So once again, we see that the original is 047. We add 2 to each one of them, and there are no common tones under this transposition. What about 3? T3 of 047 is 3, 7, 10. Now we do have a common tone, that's 7, or the note G. So let me just add a little bit more here. So we see the original chord, the original set. Sorry, something here doesn't work. Here we go. This should be example 1-3. Let's run it again. Our original chord is C-E-G, and a 3 half steps transposition of C-E-G is E-flat, G, B-flat. That did produce a common tone under T3. And our question is why? And also how can we generalize it? So it would be very easy to see if we just took the original chord, 1 step, 2 half steps, 3 half steps, now we have a common tone G. But how many other transpositions would give us common tones? You might want to start thinking about that. If I continue to go up, E major also gives us a common tone, that's E. F major has C, we saw that before. But then I get into next, F sharp does not. So we want to somehow be able to say, sorry about that, why do we get these common tones here? And how could we know in advance with any set what common tones would we get? Let's try it with a diminished triad. So I'm going to define the diminished triad here. And I'm going to just generate 4 different transpositions. And at 0, at 1, at 2, and at 3. And you notice that here, we don't have any common tones here, right? 0 through 6, 1, 4, 7. None here, 0, 3, 6, 2, 5, 8. Here we actually have 2 common tones. So again, there's a lot of different possibilities with different types of sets. And what we want to know, what we want to be able to do is generalize it so we can predict and plan either our analysis or our compositions to figure out what common tones we will have.